Welcome to qnawire.
For this question, the only thing that we need to remember is that the fundamental frequency for a diatomic molecule, taking into account the harmonic oscillator approximation, is equal to 1 over 2 pi square root of k over mu, where mu is going to be the reduced mass. Remember that the reduced mass is equal to mass 1 times mass 2 divided by mass 1 plus mass 2. So in this case, we don't actually need to calculate the frequency, so we don't need to transform the masses of the atoms into kilograms and calculate the actual values. And we're told that K, we're assuming, is equal for all the cases. So the only thing that we need to calculate is the reduced mass for each of the molecules that we have. The larger the reduced mass of the molecule, of the diatomic molecule, the lower the frequency that we're going to get. So, in the case for carbon oxygen, we can calculate the reduced mass as 12 times 16. Of course, this is, atomic mass units instead of UMAs. Atomic mass units times 16 divided by 12 plus 16. And of course, here as well, atomic mass units. And here, atomic mass units. So the result is 6.857 atomic mass units. We're going to do the same with carbon chlorine. The value over here of carbon chlorine is equal to, now we're going to have 12 atomic mass units times, let's take 35.45 atomic mass units divided by the sum of both of these guys, which is going to be 47.45 atomic mass units. So now we're going to have 8.96 atomic mass units, actually 965, but it really doesn't matter. And finally, what we're going to get is carbon-carbon. So the reduced mass for a carbon-carbon bond is going to be 12 times 12. Again, atomic mass units, divided by the sum of the two, which is 24 atomic mass units. As you can see, this is directly equal to 6 atomic mass units. So the one that has the higher frequency, it is going to be the one with the smallest reduced mass. So in terms of frequency, remember this is frequencies, we are not yet at wave numbers. What we're going to have is the following order. First of all, the one that is going to have the higher frequency, the fundamental frequency, as I mentioned, is the one with the lowest reduced mass. So carbon-carbon is going to be higher in frequency than carbon-oxygen, and in turn it is going to be carbon-chlorine at the very end. And the frequencies are in increasing order. Now, times the square root of K over C. Sorry, of K over mu. So the order is going to be exactly the same. So with this, we can answer the questions. In the case of question 1, we have CO versus carbon chlorine, which is going to have the higher wave number, as we mentioned. It's going to be carbon oxygen. And next up for 2, we're going to be comparing, again, CO versus carbon carbon. And now the one with the higher wave number is going to be carbon carbon. And that would be all. Thank you very much and have a good one.